Hello, let's just work through the second example in section 5.3, we just discussed. This is a question of compound interest. It says, how long will it take to $10,000 to grow up to $15,000 if the investment earns an interest rate of 12% per year, compounded quarterly? Okay, so the formula to use here is A equals P times 1 plus R over M to the M times T. All right, so here A is the grown money, the money it will grow to. P is the original deposit, or we call it principal. R is the interest rate each year. So that's the yearly interest. In here is just 12%. M is the number of compounding in each year. So that'll be 4 in this case, because the interest is compounded quarterly, and that's all usually the case in the bank. Okay, it just calculates the interest quarterly. T is the number of years of deposit. Okay, so we can write down these numbers. P equals 10,000, and A is 15,000. So all right, R equals 12%. And it's usually more convenient if you write this percentage in decimals. Okay, so 12% means 12 divided by 100. So that's just 0.12, isn't it? And then M equals 4, as I said, that's the number of compounding each year. And we'll try to solve for T from this equation. So we're given P, A, R, M, so we can solve for T. So just plug in those numbers in the equation or the formula. We got what? 15,000 equals 10,000 times 1 plus, okay, let me just put the formula in here. 1 plus 0.12 over 4 to the 40th power. Okay, so we can simplify this equation by dividing by dividing by 10,000 on both sides first. Okay, that'll be the first thing we do to make the equation a little simpler. Okay, so let's just divide by 10,000 on both sides of the equation. So the left hand side is just 15,000 over 10,000. And at the same time, we can also simplify the base. Okay, 0.12 or 4 is just a 0.03, isn't it? Okay, now 15,000 over 10,000, just a 1.5, isn't it? So it's just rewrite that. Okay, so we got 1.5 on the left hand side. And oops. On the right hand side, you know, inside the parentheses, 1 plus 0.03 is 1.03. We can do that to the 40. Okay, I guess I need to. Okay, just copy this and change the base to 1.03. So just do that. And then just like we solved the equation in 5.2, what we do is we just take logarithm. Okay, we can take natural log on both sides. Okay, so we got ln 1.5. If we do that, that's the left hand side equals ln of 1.03 to the 14. Okay. All right. And then, you know, again, we can use the properties of logarithms to rewrite the equation a little bit. So the left hand side is just 1.5. That doesn't change. The right hand side will be 40 times ln 1.3 if we do that. Okay. Okay. Remember, you can pull down the exponent in front of the logarithm. When you take the logarithm of an exponential, the exponent goes to the front of the whole thing. Okay, so then now we can divide by 4 and then 1.03 on both sides to solve the equation. Divide by 4 and then 1.03 on both sides. So then what we get is, you know, t equals, okay. So the right hand side just becomes t. We can move it to the left hand side, and then we can put the other things on the right side. So that'll be ln 1.5 over 4 1.03. So if we use your calculator to do the computation, I believe it's 3.43. So that's the answer. 3.43. Okay, so that's what we got before. So that's the answer. All right.